studio audience. Hey guys, this is section 6.2, properties of parallelograms, and we just talked about how a parallelogram is a four-sided figure or quadrilateral with two pairs of parallel sides. Yes or no, you guys have a parallelogram next to this, next to your... Okay. Yes. So go ahead and on your parallelogram, put your diagonals from corner to corner. So put those diagonals from corner to corner. We're going to fill up, as we do pieces of these, as we hit these theorems, we're going to fill in our quadrilateral. Okay. So the first property of a parallelogram is that its opposite sides are congruent. So let's put congruent mark on the top and the bottom, and then a double congruent mark on the left and the right. Double. That shows that the top and bottom are congruent, and the left side and the right side are congruent. Theorem 6-4, if a quadrilateral is a parallelogram, so if they've given us that information about being a parallelogram, then the opposite angles are congruent. So that looks like the angle along that is connected by the diagonal is congruent to the one opposite it along that diagonal. So then we do two congruent marks for the other opposite angles. So opposite angles are congruent. Check. Theorem 6.5, if a quadrilateral is a parallelogram, then the consecutive angles are supplementary. So we're going to call this corner A and this corner B, and we're going to say that the measure of angle A plus the measure of angle B is equal to 180. Consecutive angles are supplementary. And then last but not least, if it's a quadrilateral, then our diagonals bisect each other. Now this is going to get crazy, so if you're okay, I'm going to eliminate A and B so that you guys can see on the diagram. So what happens when the diagonal is cut in half? I'm left with the bottom congruent to the top. So you're going to do three congruent marks along one diagonal congruent to the other side of the diagonal. And then the other diagonal is going to get four congruent marks. 4. So please note that when it bisects the diagonals are not congruent. The two diagonals are not congruent to each other. They're not the same length. So when we cut it in half, if along that diagonal gets cut in half, but it does not compare with the other diagonal. Okay. So let's use those pieces of information to find our measures in example 1. So if I have this shape here, and I want to find JH, JH is congruent to FG. And so JH is equal to FG, which is equal to 23. So as you guys are going, how do I show my work? If you just put the congruent marks on it, that's showing your work. I'm not asking like the world. I don't want you to write a paragraph when it's just a simple calculation. But I also want you to show good faith that you're actually thinking and not just copying it from somebody's paper or the answer key. So the next one we're going to find is the length of JK. JK is right here. He is the same as KG, and KG is 16. So just putting equals KG and equals 16, that's a sufficient amount of work to get full credit. The next one we want to find is GH. He is congruent to FJ. Oh, sorry, he's equal to FJ, which is equal to 19. You guys feel good about that? All right, so we're going to, in example 2, look at not the sides this time, but the angles. So we know that the angles across from each other are congruent. So angle A is equal to 78. And angle B and angle D are going to be equal. And these two guys on the bottom, when we add them together, are going to equal 180. What is that? Okay. So the measure of angle B. So I'm actually gonna, we did this. Measure of angle A is 78. We can subtract that from 180 to find the measure of angle B. Is that 102? Because A and B are supplementary, they're still consecutive. And even if you didn't like that, A and D are supplementary, and B and D are equal. Is everybody okay with the measure of angle B being 102? And then we want to find X. So if angle B is 102, then 3X is equal to 102. And X would be 3 goes into 10 3 times, with 1 left over, 3 goes into 12 4 times. X is equal to 34. So there's a bunch of different ways you can combine these guys. D and C are supplementary, A and B are supplementary, and then across the way, the diagonals, they're congruent or equal. So taking a look at example 3, we don't have numbers other than 0. So we have a parallelogram. The corner is at A, which is at 0, 0. The right-hand bottom corner is at D, which is at Z, comma 0. So we're going to have to rise above and think of what distance did I travel from A to D horizontally? How far did I go? If I'm standing on A, how far did I walk to get to D? It's not 2, it's a Z. We went Z distance. So if we have a parallelogram and we start at B, we are also going to travel a distance of Z. But if you look, C is not the same coordinate as D. What is the distance horizontally from the y-axis to point B? What's the distance horizontally? X. So if I were at the y-axis traveling across to C, my coordinate, my x coordinate for C is going to be x plus the distance Z. And my Y value, how far up I have gone, that's the same as B's Y value, so it is also Y. So that's how we use the property of a parallelogram and some really funky floaty numbers to get a coordinate. I know it's counterintuitive. We've been asking y'all to solve for stuff for so long that to get a letter answer is kind of, it's a little dissatisfying, but we can muscle through that. Okay, so now let's go ahead and indulge ourselves in that urge and find X, Y, and Z. So we're actually solving. We'll actually get real numbers. This is exciting. So I want to look for letters that are the same. So I'm doing a little eval. I got 4Y here. I got an X here. I got a Z here. And I got an X here. X, Y, and Z. I'm going to want to focus on the X's first. So how are these two angles related? They're on the diagonal, so Jack? They are equal. So when they're on the diagonal together, they are equal. So go ahead and set them equal to each other. And how I remember this, parallelograms are there. Very transparent ladies. They tell us exactly what's going on. If I have an acute angle here and an acute angle across, the acute angles are going to be congruent, are going to be equal to each other. The obtuse angles are going to be equal. So visually on a parallelogram, what things look like, there's no way to not draw it to scale when angles happen. So I like the parallelogram because things that are equal are going to look equal. Things that are supplementary are going to look supplementary. All right, so let's subtract 2 x's from each side and add 18 to both sides. And when we do that, we get our little guy x is equal to 30. That is one of the answers we were seeking. If x is equal to 30, let's go ahead and find what this angle is. 2 times 30 is 60, plus 12 is 72. So now that we have 72, we can solve for y and z. Which one do you guys want to do first, y and z? Are we going alphabetical or are we going rebel? Double, all right. So we're going to say 3z plus our 72. So these are consecutive angles. They add up to equal 180. So 3z plus 72 is equal to 180. They look supplementary, and they are. We're going to subtract 72 from both sides. 3z is equal to 108. And so z is equal to 3 goes into 10 3 times with 1 left over. 3 goes into 18 6 times. Z is equal to 36. That takes care of that one. And we know that if 3z, this angle down here, is 108, then 4y also has to be 108. So when I divide both sides by 4, 4 goes into 10 2 times with 2 left over. 4 goes into 28 7 times. So y is equal to 27. And check, check, and check. Reread the problem. Okay, there you go. Darn it. I'm not going to hold the plane for 30 more seconds. We did that. Okay, so let's prove this. We have, so let's put the information we are given. If it's indicated a parallelogram, then we know BC is congruent to AB, and we also know that BA is congruent to CD, because the definition of parallelogram is that the sides are congruent. We also know that BC is parallel to AD. Technically, BA is also parallel to CD, but I'm not going to write that down because we're not going to really use that. Okay, so we want to prove that AB is congruent to CD and BC is congruent to DA. So we're going to pretend like we don't know that information, and that's going to be the last on the list. So are we proving, we know after we do angles congruent, what did we do the next chapter? We proved a bunch of stuff about triangles. So we're going to prove two triangles are congruent, and then corresponding parts of congruent triangles are going to be congruent. That's where we're going to hit that. So let's do our statements and our reasons. All right, so let's put our given down. ABCD is a parallelogram. I'm just going to draw the shape of a parallelogram. And then let's say that BC is parallel to AD, because that's the definition of a parallelogram. Minimally, the lines need to be parallel. It's in the name, guys. It's in the name. It's like having hot sauce that's not hot. It's in the name. I know. I know we want to say that, but we're gonna prove it. I know, but we're gonna prove it. I know we want to say it, but we're gonna prove it. Okay. So if I have, so we are proving that sides are congruent. Which side can we for sure say? Which one's my overlapping side, guys? We're going to reflexive this, guys. Which one gets the reflexive? Yeah, AC. So AC is congruent to AC. Reflexive property. So let's go ahead and put that congruent mark there. And then we're going to say that the angle BAC, oh, angle 1, thank goodness. Angle 1 is congruent to angle 4. Because alternate interior angles are congruent. And that applies to 3 and 2 as well. So we're going to put that underneath 4. Okay, so now let's count it up. Look at our triangle. We've got an angle, a side, and an angle. So we can say that triangle, I need to look at it, ABC is congruent to triangle CDA by angle, side, angle. So when you know your two lines are parallel, you can always grab, because of that parallel property, you can always grab 2 angles off of that. And that leaves you with, if you can get another side, like we found that reflexive side, then we can do triangles congruent. Okay, so lastly but not leastly, let's go ahead and prove what we came here to prove. AB is congruent to CD and BC is congruent to DA because corresponding parts of congruent triangles are congruent. So AB congruent to CD and BC congruent to DA. C, 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 C. And please remember, if you have stuff left over because you're not proving the triangles are congruent or you're going beyond that, the end goal isn't the triangle congruence, remember the next item is going to be CPCTC. Okay.